Is that Stefan Lamans I see? Hello. How are you, Stefan? Oh, I gotta figure out how to share my screen. Hey, I'm reading that book you recommended. It's very good. The design patterns book. I should have read it before. All right, where's the share my screen button? Is it not right there? There we go. Screen share. Stefan. I started reading here. It is. Malcolm, hello.
Oh, Daddy, if you want to crouch, just press C. See? Press C to crouch and press C to get back up.
All right. Thank you, Harry.
Yes. Oh, oops. Wrong person. Yes, I noticed that. So can everybody hear me? Perfect. We've only got like 6 people, but a whole bunch of people signed up. So we're gonna wait another minute or so maybe to see if anybody else shows up. Looks like everybody's piling in, so that's good. Can everyone see my screen? Hopefully. Good. Perfect. All right, we got 7 or 8 people, so we'll go ahead and get started. Everybody else will miss out in the first minute or so, but that's okay. So, for those of you who don't know me, oops, how do I hide this thing? All right, so my name is Sam Taggart. You can read a little bit about me there. I've got all these acronyms and stuff. I run a small company in Golden, Colorado called System Automation Solutions, and we work on partnering with LabVIEW development teams to make them more efficient and effective and help them to take on bigger and better challenges. That's kind of what we do. If you're not muted, if you could go ahead and mute yourself. If I can figure out how to do it here, I thought I had everybody muted, but apparently not. All right. So if you're coming on, if you could mute yourself, that will save me the trouble of having to go through here and mute everybody. All right, yeah, if you have any questions, go ahead and throw them in the chat as we go. So this presentation is about test-driven development, and I have the /design and the question mark there because this is a discussion that Fabiola had when I did our workshop at GDef Con, the most recent one, and she kind of brought up this point of, is it test-driven development or test-driven design? And I think in actuality, it's probably a bit of both, right? We design our code differently when we know that we need to be able to test it. But what I'm going to focus more on is the development process of how tests fit into writing code. But it does kind of a bit of both. And part of the motivation, and part of the motivation for Fabiola's comment was that I hear this, and there's a typo. Fix that while I'm here. So, you know, I hear from people, oh, I tried this unit testing thing, but I don't like it because I have this existing project that's this really huge project and somebody else wrote it and I inherited it and now I've got to write unit tests for it, right? And I don't know where to start and it's too hard. And the truth is that is true because what happens is, and I'm stealing an analogy right from Fabiola here, so sure. Mute that person. All right, if you're muted, please mute yourself. Somebody is not muted. Who is not muted? Ah, there we go. Got him. So, right, if you're circuit boards and somebody designed this great circuit board and it looks something like this, and it's got multiple layers and you've got these ball grid arrays and other chips, and the signals that you need in order to test it are hidden on the inner layers or come up underneath chips, right? And you can't get them to test them, right? You either can't test it, or if you have to test it, you send it back to the designer and say, hey, redesign this board and move these traces and give me some test points so that I can test the points that I need to be able to test. And it's with software, right? If we have software that was written without thinking about how are we going to test this, what values do we need to be able to read and what do we need to be able to see inside the software, then when we go to test it, we're like somebody trying to test a multi-layer circuit board where everything's hidden in the inner layers. It just can't be done. So definitely the testing part and knowing that you have to test it will change and affect the way that you design it. So basically I came up with two conclusions out of this whole example, and this idea is, one, retrofitting unit tests is hard. And that's because it wasn't designed with testing in mind. So it's not easy to access the things that you need. Let me see if I can just pull up the chat to make sure that I'm not missing anything going on in there. I thought I had it up. All right, cool. That's the first thing. And the second thing is learning unit testing is easiest on a new project, right? So when you start a new project, if you want to learn how to unit test, don't pick some big old project that you have that's been around for a while. Pick something new and start out with that. And I think there's really this like learning curve on unit tests. And you have to get to a point where you have a project with a bunch of unit tests in it, where everything's unit tested before you really see the value, right? Because the value comes from, oh, I made a change over here. I ran my unit tests. And now everything's broken. If you're not muted, please mute yourself. Hey. And whoever is not muted, please mute themselves. Thank you. I don't know why it doesn't automatically come on muted. I'll have to play around with the settings and see if I can figure that out for the next one. Right? So if you're trying to learn unit testing, don't start on a new project. Or sorry, don't start on an existing project, start on a new project. And employ some of the techniques that I'm going to show you today about test-driven design. Okay, so I gave this presentation at GDef Con #2, which was in English here. And Fab has been pushing this "Our Giants Are Female" thing. And basically the whole thing comes out of the, I think it's Newton quote that says, you know, stand on the shoulders of giants, that, you know, nobody's reinventing the wheel. We're using stuff that people have created. And so her point that there are plenty of them who act as giants and we don't really recognize them. So I happened to go to a museum when I was in London, and they had an exhibit on the moon and the lunar landing, and I saw this and I thought I would add this. So apparently Margaret Hamilton worked at MIT, and she helped write the software for their onboard computers. And I'm guessing that's all the tape, right? Computers. And it's kind of humbling because, you know, we squabble, we've got our, you know, PXI chassis or Rios or whatever, and we struggle to make them do what we want them to do. And these guys had, you know, something that's less powerful than the phone in your pocket, and they had to make it go all the way to the moon and back. So I think that's an interesting thing. So speaking of GDef Con, there is a group of us who are getting together to try to bring GDef Con style conference to North America, probably to Denver, quite likely next summer. So if you're interested in that, stay tuned. There'll be more information coming out. If you really want to get involved and help out and plan it, please let me know. We will take all the help that we can get. And if you happen to think that you or your company would be interested in sponsoring such a conference, then please let us know as well, because we are looking for sponsors. All right, so a lot of the stuff that you're going to see and hear about today comes from this book that I read called X-Unit Test Patterns. And it's about refactoring test codes. The main point of the thing is, if you're for all your code and your code base grows, then obviously the number of tests grows as well. And they get kind of unwieldy. And so it's got a lot of good tips and tricks for how to manage that so it doesn't control. And it talks a lot about unit testing in general as well. This happens to be 900 pages, and it's about 10 or 12 inches thick. It's a beast. I don't really recommend it unless you're having like specific problems with, I've got tons of tests and I'm having trouble managing them. Fabiola recommends this book. I have to say I've not read it. It is sitting on my desk along with a pile of other books to read. So I will get around to reading it soon. There is a new edition coming out. So if you wait a month or two, you might get the 3rd edition. So this book, I can tell you, I have it sitting on my desk. It's much thinner. It's maybe like 200 pages. And I've skimmed through and it seems much more approachable. So, and I will do one other plug before we get into the meat of the presentation. And that is this AST Testers named Dan Shangra. And he put this on the LabVIEW Tools Network. And I like it just because it's way simpler than JKIVI Tester. I'm still a JKIVI Tester fan, and when I go through some examples here, you'll see that that's what I use. But if you're working with people who have issues to understand object-oriented code and you just don't want to mess with that, this boils unit testing down to the simplest thing. It's got a really simple GUI. Your tests are simply VIs in your project, and they've got 3 requirements. It has to start with the word test. It has to have this hashtag up in the left corner here that you see, AST_unit_test. And it has to have a matching connector pair, basically error in, error out, and a pass Boolean. As long as it has that, it will find them and run them. And so in this case, the example on the right, we're testing the adding function, and we're saying 1 + 1, the output should be 2. If that's true, we output a pass. If it's not, we output a fail, and that's our test. And so, of course, you can substitute the add function with whatever code you're trying to test and make your own assertions as far as what needs to be true in order for that test to pass. So really simple. I really like it. Quick question, actually, if you could throw in the chat what unit testing tool you're using, if you're actually using any, just so I can get an idea of who is using what. That would be a little helpful, just out of pure curiosity. So we got some JKIVI Tester. My impression is that that's the most popular, although I hear from a lot of people like Karaya as well. So those of you who aren't using unit tests, that's fine. I highly encourage you to start though. So I think you will write much better code and have a lot easier time. And I think too, I was listening to this podcast just recently, and it's on maintainable software, I think, or maintainable is the name of the podcast. I highly recommend it, but they had somebody on there. They were talking about how people don't unit test because like, oh, well, my boss isn't going to pay me to do that, blah, 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 blah. And the lady made the point, she's like, well, if you want you to design some kind of state machine and you take a bunch of time drawing out notes by hand and doing this stuff, you don't ask permission for that. So, if you're not unit testing because you're like, oh, my boss won't give me permission, I'm going to tell you, just take charge and do it anyway. Because you're probably already writing code, writing stuff to test your code anyway, right? You're doing some sort of ad hoc testing, so just formalize that and make it unit testing. I see an Insta coverage on there. I just playing around with that recently. There are some things about it. There are some things I don't like about it, but I will give them props because out of all the ones that have the most active development right now, so they're out fixing bugs and stuff as we speak, and they're also the only one for NXG so far. So the paradigm is similar but slightly different, just the way you execute it. That's part of why I'm not a huge fan of the way they have it broken up, but if it works for you, that is awesome. And Peter's a good guy, so. Okay, so here's kind of the meat of the presentation. I'm about to start here. So there are two things that we need to know before we start any project. And I got this from Steve Watt's book on, what is it called? I have it sitting here somewhere. Software and Approach to LabVIEW. So Mark in the questions asked that they just started using Actor Framework and they good unit test tools. It will all work for testing actors. You should look up Alan Smith's presentation at the recent CLA Summit. I don't know if the video has been released yet, but when it is, it has a lot of stuff on there on testing actors. So it's much the tool, it's kind of how you set up the test. Yes, Insta coverage. You say Insta coverage, so AM says they really like Insta coverage and that works with OOP. They tout that on their website. I'm not sure what kind of OOP integration they have that other tools don't. So I use JKI VI tester and I test OOP stuff and I don't really have a problem. So I'm not quite sure. And Stefan did an example on unit testing actors, so that's also worth looking at. Yeah, website video, yeah. So Mark commented that would probably be the video from the CLA Summit, but he probably has some other ones as well. Thank you, Stefan, for sharing that. All right, so back to this realization that there's two things that we need to know before we start a project. So Steve was talking like a macro level, and his was that the first NI unit testing framework does not work with OOP AEM, by the way. Well, does and doesn't. You should look up Fabiola's presentation. She talks about how you can use it with LVOOP, but you have to jump through some hoops. So Steve was talking at macro level that when you start a project, the first thing you need to do is define your requirements, where you're going, right? What your plan is. And then, so that's the first part. Right? Where are we going? We got to have a plan of what we want to do, define what we want to accomplish. But then there's another part, and that is, how do we know when we get there? And from Steve's point of view, he's talking about projects, and he does a lot of fixed price projects. So for him, it was very important to have a test plan at the end that you could say, okay, we did what you said, we checked all the boxes, now it's time to pay us. And for fixed price projects, that's really, really important, right? So you have to know when you're done. And if we think of that on a micro level, right, we break down from big project to we're going to add some feature, we're going to add a class, a VI, something smaller. Unit testing really gives us both of those two things, right? If we write the test first, we specify what we want the software that we're going to write to do, right? And so that tells us where we're going. And then the verification part is really easy. If we write that out as a unit test, instead of writing it out in some Word document, we write an actual unit test that says, if I give it these inputs, this is the output I expect. Then it's very easy to verify whether we're there or not because we just run the test, right? So you write the test before you write any of the code. That's the whole TDD part, which we'll get into in a second. You write the specification. And one of the things I recommend, a lot of people recommend, is run the test first to make sure that it actually fails, so you're not getting a false positive, right? So you don't have a test that's always going to pass. But you verify that the test actually fails, and then you go about your development. And then at the end, you know you're done when the test, all the tests pass. And so really it's about changing your mindsets, changing the way you think about writing code, because often we just want to jump right in and start writing code. And tester environment says, hold on a second, right? Before you write any production code, write a test first, right? Don't write a test to test your code. Write a test so that then you can write code to pass the test, right? And it's often kind of iterative, right? So you'll come up with a set of tests. You write your code to pass those tests, and then you'll think, oh, well, maybe we should add a couple more requirements or a couple more things that we need to test. Okay, let's write the test for that. Then let's see if our code passes that test. Okay, then we'll go change some stuff. So it's just a completely different mindset. You have to take a second and like stop what you're doing and step back. And it's hard to do because, I mean, I admit when I see a problem, I just want to jump right in there and solve it. But writing the test first definitely adds a lot of value, as you'll see throughout this presentation. So here's the basic process, right? So we decide we're going to add some new feature, right? We write a test or multiple tests to test that feature. And we haven't implemented yet, so we verify that the tests fail, right? So we run the test, they fail. Okay, so now we know that the tests actually catch what we want them to catch. Then we write our code that's supposed to make the test pass. And then we run the test again. And if the tests don't pass, or if we break something somewhere else, then we go back and we write and edit more code, or we undo our changes and try again, right? Whatever we need to do there. And then once everything passes, before we move on to the next feature, this is important. I left this out at GDef Con #2. We should do this refactoring step, right? And all refactoring is, it says, okay, we've got tests that pass. We got this code, but this code is probably not as good as it could be, right? We can clean up some wires, we can move some stuff around, we can rename some stuff, make it easier to read. So you take like 5 or 10 minutes and do that, and then run the test again. And if the test pass, then you move on to your next feature. If they don't pass, then you go back and refactor a little bit, figure out what, you know, when you're moving stuff around, maybe you disconnected something you shouldn't have or something like that. And then you go on to write your next new test feature or next new feature, right? And then you start all over again. You start with the test, you verify it fails, and you just keep looping around. Right? But this refactoring part is actually key because it kind of helps your code from getting to be spaghetti code, right? Because when you got the test, you just write whatever you can to make the test pass, and your goal is to make the test pass. The refactoring part is taking a step back and saying, hey, I need to make this maintainable for myself and whoever comes after me. So that's kind of an important step. Any questions so far? If you do, please feel free to throw them in the chat. So you might be thinking, well, that's great. I should write the test first, but I haven't even written my BIs yet. So how the heck do I know what to put in my test? And that is a very valid question. In text-based languages, you can write the test and you just make up the name of the method and then go write the method later. LabVIEW, you can't really do that because LabVIEW needs to know what the signature of the method is, and the way that's defined, right, is through the connector pane. And if you don't have a VI, you don't have a connector pane, right? So you got this problem. So you actually have to write the API first. So before you write your test, you got to give some thought to what your API is. Right? So, and this is actually a good thing because it really makes you think about your API and it makes it much more well thought out. All right, so I'm going to go through a real world example. This is a toolkit that I put together, and you can see the web address there for GitLab to go take a look at the source code if you want. I did get it put on the LabVIEW Tools Network, so it doesn't have a landing page yet, but it is available. So if you search for SAS TDMS headers, you'll find it, and you can download it. That's just the built code. That doesn't include the tests. If you want to see what the tests are like, which is kind of the whole point of this presentation, you can go to the GitLab page and take a look in there. There's a folder full of tests. All right, so this is what I'm trying to avoid. Just to show of hands, how many people use TDMS files? I'm sure probably a lot of you guys. So if you're not using TDMS files, you should be, because they're way better than CSV files. I just had somebody ask me about CSV files this morning and send me an email, and I sent them back an email and said, yeah, you could do that. I was like, or you could use TDMS files, which are much better. So one of the nice things about TDMS files is that you have this hierarchical thing of channel files and then groups of channels and then individual channels. And at each level, you can store a whole bunch of properties, right? So at the channel level, you could store like individual sensors. Maybe at a group level, you store UUT information. Maybe at the file level, you store some information about the date and time the file was created and who created it and what tests they ran, etc. Right? So the downside is, if the properties have different data types, you have to write each one individually, right? So you end up with stuff like this on the left and right, where you have to, you have a cluster full of properties for your channel or your file, and you've got to unbundle each one separately and write it in, and you got to come up with a name for it. And reading them back is the same thing. You got to have the name, and you got to know the data type, and then you got to bundle them all together. So it's kind of a pain. And it's all right to do once, but man, it does not scale well, right? If I want to add another property, I got to go into my properties cluster, add another one, then I got to unbundle that. I got to drop it or insert another set property node, and then I've got to, get it on the other end, and it's a pain. So what I wanted was something similar to these MGI read-write anythings, or I think OpenG, also our JKI has one, right, that lets you take a cluster and you write it to a config file or INI file, and basically the name of the cluster becomes the section, and each element, the name becomes the name of the thing inside the INI file, and the data types all match up, and everything's nice and easy. So you don't have to do all this unbundling and stuff. And so I decided that I would design something similar to that, and I decided that I would also take advantage of the fact that we have VIMs now, and so we can make this a VIM that kind of adapts to whatever you wire in. And so I came up with this API design, right? So in order to write to a TDMS file, you pass in a path, and I made it accept paths or references, right? So if you pass in a reference, it just leaves the reference open and uses that. And if you pass in a path, it will open and close the reference for you. So I thought that was kind of slick. And basically, you wire in the cluster full of data that you want to write, and you give it a group name or channel name if you want, and it'll write to the file. And it goes through the elements of the cluster and pulls off the names and pulls off the data types, and then does all the stuff it needs to do to make that work. And then reading is similar, right? The nice thing I added the ability to, if there are missing elements of your cluster that don't exist in the file, right? You could pass in default values. So whatever you pass into data to read that cluster, that also defines the default values. And so if something's missing, it'll tell you it's missing, and it gives you a list of all the properties that are missing, but they all have values. So you can set default values, and you don't generate an error unless you want to, right? So you can use the missing flag to generate an error if you want, or you can just accept the default values and move on. So I thought that was kind of a slick API. And so I started to get the API to actually work, right? Because it's a VIM. I had to write a little bit of code, and I probably could have got away with a little bit less, but this is what I wrote just to get the VIM to work. So if you don't know anything about VIMs, that's okay. But basically all this just makes sure that the data types that you're passing in are actually the data types that will work, and that everything coerces correctly and all that. And that was actually a little bit of a challenge in itself, trying to get that to work. So then when I dropped it into the test, it would coerce the right way. But that actually made the test really useful because, I wanted to make sure that everything coerced correctly. So do people play around with VIMs? How many people have actually done stuff with VIMs? Anybody? I think I saw Stefan just said yes. So they're quite useful. They adapt to type. They let you do some really fancy, interesting things. If you end up writing a bunch of, what are the VIs, a pull down thing? God, my mind. Not express VIs. Geez, I can't remember that. But polymorphic VIs. So if you make a lot of polymorphic VIs, thank you, Mark. If you write a lot of polymorphic VIs with the selector and stuff, you could often replace those with a VIM, and it will automatically adapt just easier. There's still some cases where you have to do polymorphic VIs, but in general, if you're doing polymorphic VIs, VIMs are better. Yes, they are quite useful. So, okay, I've got my API now, and I've decided I want to write my test first. Well, I really have to write my API first, but now I'm ready to write my tests. So how do I decide what to test, right? Because I've got an infinite number of possibilities, and because I made it a Vim, I've got infinitely more possibilities, right? Because I've got all the different data types that it can accept as well. So the first thing I always try to test is what I call the happy path. So if everything works well and they're using it exactly like I expected, how do I expect it to be used? Right? And then maybe some other common paths that I expect that, okay, you know, I execute and then write the same cluster full of data, okay. Maybe I also expect them to be able to write a cluster of data later. Maybe they read it back and they added something to the cluster that's not there in the file. So then I have the deep values that come in and the, you know, the flag that tells you that something's missing. So that'd be like the other common paths. And then maybe I test some corner cases, maybe where they pass in some weird data types that I'm not expecting, you know, make sure it generates an error, something like that. Error paths, right? So what could go wrong, right? If I try to write to a file that doesn't exist, something like that. So anything that could cause an error, make sure that those get generated and that works. And that's kind of how I prioritize, you know, testing all the error paths and stuff. I mean, if it's a critical thing, they're like, hey, if this doesn't work, it absolutely generates error, then maybe I move that up and that becomes more important. But otherwise, I tend to relegate a lot of that to the last couple things I check. So the thing I did was I wrote one for my happy path. And basically my in this case, the happy path, and I'm stealing that term from the book I read, is basically I have a cluster full of data. And so the type def there that says valid types, that is as one of every kind of data that you're allowed to put in a TDMS header. So TDMS headers have like a set of data types that they accept. That cluster contains one of each. And then the sub-VI basically just takes that and sets each of some non-default value. So in my setup, I create a blank TMS file, temp file. I kept this cluster that's got non-default values. And then in my exercise, I write that to the file. And then I route that back from the same file, same type, right? But my valid types, the cluster that I'm using to read back has the default value. So I want to make sure that I'm not like glossing over reading something and just the default values happen to match. And then I'm combining them. AMS, why do I have a setup and teardown in the same VI? So in JKI VI tester and in the XUnit stuff, there is a setup and teardown VI. The setup will execute for every single. So as it goes through and picks out all the test methods, if you put something in the sub VI, it executes before every test, and the teardown executes after every test. But in this case, I'm setting up stuff specific to this test. So that's why I didn't use the setup and teardown methods. Because otherwise it would run the same setup and teardown for every test, and I don't necessarily want that. Hopefully that answers your question. If you have something that's repeated that's done for every single test, then yes, you could put it in the setup and teardown. And I think all the other ones have this idea of setup and teardown. All right, so if you're really into unit testing, you might have looked at that test and you might have cringed a little bit, right? Because when it comes to unit tests, that's really actually not quite a unit test. It's more of like what I would call like an integration test. Because I think of unit tests as when the unit test fails, I know exactly where to look. I know exactly which VI failed. In this case, if I run this test and it fails, well, what's the problem? Is the problem that it didn't write to the file? Is the problem that it couldn't read from the file, that it couldn't get the correct data type? Maybe the key's missing, right? So there's all kinds of issues here. And it's a good smoke test. It tells me that everything works, but it doesn't really localize the problem. So I'm well aware of that, but I needed something to get off the ground to start writing some code, and I need a test, and so I started with this. And you'll see as we go along, I'll show you the other tests get way more granular as far as determining exactly what's failing. So I wrote my test. So I started out, right, I decided I wanted to build this thing. I decided I wanted to write the test first. I couldn't write the test, so I created my API, right? So I created my two VIMs and I wrote up my description and set up all my inputs and outputs. And then I wrote my test. And I haven't written any code yet other than the little bit that I needed to make the VIMs work correctly. And now I run my test and the test fails, which is good because that means, hey, you know, the test will detect if it's not right. It's not going to automatically pass. So then I wrote some code for my happy path, right? And basically all I did was I added a sub VI there, and it takes my cluster variant and it turns it into a bunch of different variants. And then it pulls off the type or the name and it writes into the file. And that works. And the write to TDMS file is totally happy with that. And that all works. And I know because I then and ran the test. And then here's the read. And I basically did the same thing. I put in a sub VI and I just did something similar, except that this time instead of writing from the file, from the TDMS file, I'm reading them. And then to get into a variant form that will then allow me to transform it back into a cluster, I had to do a little magic. And that's what happens in that little sub VI. But it's basically the same thing. Now, one thing to notice on the left is that I didn't wire up the missing keys or missing tags because my test doesn't check that, right? All I'm checking is my happy path of I write a cluster and then I read that same cluster back from the file, right? And so now I've got both of those. I run my test and my test passes and says, yes, you got back the same things you wrote. And that is great. So now I'm happy. Now I know I've at least added some value in that I've got a thing that if I write the cluster and I read back the same exact cluster, I get the same values. So that's awesome. But now I've got some other features that I want to add to this thing, right? So I want to add the ability to detect if keys are missing or not, right? I want to be able to return the names of the missing keys. And I also, want to test my error stuff, and I want to test that, if I pass a ref, it works. If I pass a file, it works, things like that. So then I came up with a whole bunch of other tests. And you'll see I kind of renamed my test class. And I have a convention for naming tests, and I think it's worth having a convention of some kind. So test, then the name of what I'm testing, generally the VI, right? So, or the function, and then I'm testing whether it's a file or group level, and then what the value should be that I'm expecting back. So that's kind of how it works. So I'm testing the read function, for example, like the third or fourth one down there, testing the read function. I'm trying to read a key that doesn't exist. At the file level, it should return the cluster value, so it should return whatever I passed in. And the example here on the right, it's a similar test. I'm testing if I try. So I'm creating my file. The little orange thing there just adds the group and channel, because if I try to read a key from a group or channel that doesn't exist, then it throws a different error. So I try to read a key from a group or channel. The group or channel exists, but the key doesn't exist. Then missing says true. Yes, hey, there's a missing key. And that's all I'm testing. And so I kind of broke it down very granular as opposed to my previous test that I showed you that was just this big smoke test. This is really granular. I'm testing just that Boolean output. I'm not even testing the fact that it tells you which key is missing. That's the next test, right? And I'm not testing that it passes out the correct default value. That's a separate test too. So then if one of those fails, I know exactly what part of my code to check into, right? So I had a question from, I think it was Quentin at the CLA Summit, right? We had this debate about what actually constitutes a unit test and like how small do they need to be. In my mind, it's as small as you can make it so that if something fails, you know exactly where to look, right? So it should test one tiny little thing. And that could be a class, that could be a method, that could be, one input or output. Make it as small as makes sense, but generally the smaller the better, just because this is a tool for you as a developer so that if you introduce a bug, you know exactly where to go to fix it. All right, so, I created all those tests and I wrote the code to make it pass, and everything passed and I'm done. So it brought me out to this slide, which is TDD doesn't exist in a vacuum, right? So, and that statement actually can be applied to a bunch of things. So here I was thinking more like CI, the whole tool set. But also TDD doesn't exist in a vacuum in the sense that when we do TDD, we can get this like micro focus on individual components, right? And we kind of ignore this big picture system design. So we do have to take a step back and look at that as well. So that really wasn't the original intent of this slide, but that's something that's kind of put in my head since I wrote this. I think that's also worth thinking about. But from a bigger picture of our process, right? This is like a CI/CD map of like the pipeline that I kind of had in my head when I started this project. And I thought, okay, you know, I use basically a get flow type model. At the top, now I use get flow. Before I was just basically, I had my master branch and I would just have feature branches. Get flow is slightly more complicated than that, but basically I thought every time I check something in, I want to run a VI analyzer test, and I want, you know, to make sure that I'm following good style. And if I have a JKI VI test unit test suite, I want to run that as well, just to make sure that everything I'm checking in isn't broken and looks nice. And then, you know, when I merge back into master after I've done my feature, then I want to build my VIP file so that, you know, I verify that it builds, the whole build early, build often thing. And then I wanted to do this test install. So, you know, go to a fresh machine and download the VIP, install it, and then rerun my tests, right? So I want to take the test that pointed to the library in my source code and point it to the installed library, and then run those tests again. I actually just put out a blog post about how to do that. So if you're curious how to do that, check out my blog. And then the next step was going to be, okay, after I do a release and then maybe I run some tests of my own and just install and make sure everything works manual-wise, then maybe check back in and do a release where I actually like give it a tag, and then it would deploy it, which internally I use a file server thing called Nextcloud. I throw it up on there and then send everybody on my team an email that says, hey, there's a new release of this particular thing. So that was kind of my original plan. I have a question too. How many people actually use continuous integration out there or use any kind of CI type thing, whether it's GitLab or Jenkins or something else? Ryan says yes. Yeah, I know it is a work in progress. It is definitely, there's a lot of moving parts to get together. And certainly don't feel daunted by all of this because you don't have to do all of this, right? You can do bits and pieces. And yep. Well, you'll like what I have to show you next, Stefan. So this was my grand plan, and this is what I really wanted to do. And if I had my CI infrastructure really well set up, I probably could make this work for a small project like this. But what turned out was this is a really small project. I built it once. And because I had all my tests and all my tests worked and ran, it built and it was fine. And then I went and put it on the tools network, and I had to do maybe like 2 more builds. I did one, I added some help and stuff, did a build for them. They came back with like one thing I missed, and they're like, hey, add this. I added it and I built it again. So I built it like 3 times. So really, you know, if I had the CI infrastructure already, it probably would have been easy and simple to do that, but I don't quite have all that set up yet. I'm kind of revisiting how I do that. So I ended up not using it. But to Stefan's point, you don't necessarily need a server to do some interesting stuff. So if you use VIPM to build packages, and this may be a paid feature, I don't know, I have the paid version, but you can add a pre-build custom action. Yeah, so you can have a VI that runs before it builds. And so for mine, all I did was, before you build, run the unit test. If they fail, generate an error and don't continue the build. So now my builds take a little bit longer, but not that much longer, and unit tests are supposed to be fast anyway. And so now, if I forget to run my unit tests or something and one of them fails, like I make a change and for whatever reason I don't run it, before I build, it will alert me and say, hey, you have a fail. So that's a little bit of automation without going the whole CI server route. And it's still really, really useful. So if you're doing unit testing, I highly recommend you do this. I haven't really looked at doing LabVIEW executable builds, but I'm pretty sure you can also, there's hooks in there to run stuff. Yes, so Ryan Shepard, this is locally run. This is run on my local machine. It's basically run anytime I run the build process. So right now I'm doing the build locally. If I ran the build on my CI machine, it would also run the tests first. Yeah, Stefan, we should definitely talk about more of this. Takes like maybe a minute max. I want to say it takes like 20 or 30 seconds. So it doesn't add much time. If your unit test suite adds a lot of time, I think you should probably relook at your unit test suite and read that big red book, and there's ways to reduce test time. There's a whole ton of stuff there. The other thing is, instead of running all your unit tests, maybe have a subset that you run, like these are the most important ones. You know, don't release anything where these fail. So JKI Tester lets you define unit test suites, and so you grab a suite of like the most important tests and run those. So again, this is really useful automation stuff. Do I run VI Analyzer after the unit test? I did not run that. I have some issues with VI Analyzer tests in that trying to get them to the point where everything passes is really ridiculously hard because it can be quite nitpicky and you gotta have it set up for just right. And I also had issues when I was doing CI stuff that I had stuff that would pass on my local machine and not on my server. And that had to do with font issues. So Fabiola recommended a way around that about like setting fonts, default fonts and stuff. And I just haven't implemented that yet. So I like VI Analyzer. I think it's great. But the other thing is too, I feel like VI Analyzer, right? Like if the goal is to be readable, it should almost have some sort of like artificial intelligence or something, machine learning, that says this guy is readable, this one's not. Because in my mind, the whole point of running VI Analyzer is just to make sure it's readable. And that could look different for different people or different VIs. And, you know, I'm not as concerned like every single wire straight or whatever. So maybe that's just me. But it would be really awesome if they had some sort of like machine learning thing where you could train it and say, you know, go through a bunch of VIs and say, this one's okay, this one's not, this one's okay, this one's not. But I do realize people use it for other things too, to find like little bugs in your code and things like that that are maybe useful. So I don't know, that's my 2 cents. But I definitely want to talk to you at some point, Stefan. We should schedule a call or something because I'm definitely working on redeveloping my CI process. And if anybody's in that boat, you should look at Jorg has a bunch of stuff and it's on his website, Hamplesoft. He has a GitHub page, or GitLab, sorry. He's a big GitLab person, not GitHub. And it has a bunch of stuff and it's all there. And the Compose Systems guys have some stuff on their Bitbucket account that also has some things there, and it's quite nice. Yeah, that's kind of what I need to do, Stefan. I need to go through and prioritize stuff. I also want to do some stuff where instead of running VI Analyzer on everything, it goes into Git and sees which ones have changed and only builds those. I know that's possible. I've talked to people who've done it, and I just haven't gotten to that level of sophistication yet. So yes, because VI Analyzer takes a long time too. That's the other reason why I don't want to do it as part of my build process, because, you know, if I do that every time I build the package, if I'm building it locally, then I have to sit there and wait several minutes for it to run because it's not fast. All right, so we're kind of getting close to wrap up. Stick around. I have a few things at the end that I want to talk to you guys about, but some of the benefits that I've seen. Designing my API front made for way better API design. Definitely made you think of those like corner cases and how you're going to use it. As Fab says, you become the first user of your API, so it's definitely a good way to sort all that out. And some of that stuff, like you just like you think you know how you're going to do it, and then when you start moving and you start doing stuff and you start actually using it in your test, you're like, wait, oh, I need an input for that, or I need to be able to set this or that. So. Yes, AM mentioned the CI server and builds and how you can allow for a longer build time. That is true, definitely for builds. For unit tests, I would say you want the unit tests to run as quickly as possible. So you want that quick feedback. But yes, I do agree. Longer build time is good. It is good for having a server that's off doing that. So you're not sitting here, right? If I'm building something on my computer and it takes an hour, now my computer's tied up for an hour and I go grab a cup of coffee and I can't do anything until I come back. So that is definitely where the server can save you a lot. So better API design, testable code, right? I've written the test, so I know it's testable. So that's really a plus. Cleaner code, right? In that since I'm only writing enough to make the test pass, I'm not adding extra features. It catches some bugs. I caught a few bugs while I was doing this that I didn't realize I'd introduced. And it gives you really extreme clarity about what you're doing. And the other thing too, I don't know if any of you guys were at the CLA site, but Sarah Zaleski said something about legacy code, and she was talking about that. And legacy code is code that people are afraid to change. Now, I haven't actually seen this because I pretty much work alone, so I haven't passed this off to anybody else. But I'm willing to bet if I passed this off to somebody else, they would have a really easy time making changes, right? Because they know exactly, they know when they download the code, they can run the unit test, they know it passes. If they make a change, they can run the test again and know that they haven't broken anything. So I think that's like another benefit, right? I haven't actually seen that one in action, but I would be willing to bet that that's a huge benefit. So some things that I've learned. It is a small investment, so it does take some time up front. But I consider that an investment, not an expense, right? Because it's going to pay you back in the end. Because now I haven't had to debug too many problems here, but if you do a good set of unit tests, right, and it points you to exactly which VI is the problem, right? I find when I'm chasing down bugs, a lot of the time is spent chasing down the bug, not fixing it, right? So a lot of it's trying to figure out where the bug is, and then the fixing it usually is very simple. So you're saving the time in the future on chasing down bugs. One way to lessen the investment is just copy the test. I write one test, I copy it, I change the input and output, and now I've got another test. And I copy it again, I change the input and output, and now I've got another test. So even though you're writing a whole bunch of tests, you're not writing as many as you think. You write one and then you copy them. It's about this idea of going slow to go fast, being slow and methodical and process driven, as opposed to just running as fast as you can and not having a plan. Debugging tests sucks. So spending time debugging your tests sucks. So that's the KISS principle, keep it simple. Somebody mentioned that they use Insta coverage. That is one of my critiques of Insta coverage, is that the way they have it, they have a bunch of conditional code in your test. So they have one VI that is your test, and it has a whole bunch of test cases in it, and then it has like case structures. And the case structures just kind of slow you down debugging, and just, in my mind, introduce some complexity that maybe is not needed. The different testing systems, we have one test per VI, makes it a little bit simpler. So I don't know. If you can make the Insta coverage thing work for you, again, I'm not trying to tell them that I like what they're doing. I think they're pretty awesome. But that's just one of my critiques. And the CI is really nice. And if you have it, that's awesome. Use it. If you don't have it, it doesn't always add value, and you can find creative ways to do things without it. So yeah, by all means, I'm not trying to convince you not to use it AEM, but just be aware. And if you notice that, then you can always talk to Peter too. I don't know why they use that design, and maybe it's something they can change. I don't know what the reasoning was behind that design decision. That's certainly not the way I would have done it, but that doesn't mean it's right or wrong. They may have a reason for that. I suspect part of the reason they did that was it made it easier for them to do code coverage stuff. But oh, okay, this got all messed up. Why does this get all messed up? All right, so that's more or less the end of the presentation, but stick around for a few seconds. So I have this idea for this LabVIEW mastermind group. So I run my own business, and so I joined this business mastermind group where a bunch of business owners get together, and we kind of help each other out, and we trade advice and stuff. And there's a guy who organizes it, and he teaches a class. And then we'll meet once a month to do the class, and then we'll meet a few weeks later to talk about all the things we learned and how we're applying it, and kind of help each other troubleshoot what's going on. And so I was thinking that there's an absence of that in the LabVIEW world. And so what I'm trying to do is get together a bunch of people who are really passionate about being better LabVIEW programmers, And you don't have to be the superstar developer. I'm just interested in finding people who want to learn and grow and are willing to help others do that. And I'm trying to organize something. And so if you go to this link, I would really appreciate, go to the link, give me your email address, and I will send you guys a survey outlining kind of what my thoughts are and how I want to organize this and everything. And so if you think that's something that you'd be interested in joining, right now I'm just kind of trying to gauge interest and see, if people are interested, how often they want to meet, what type of stuff they'd want to cover, like those type of things. There will probably be some charge for this because I'll put some effort into organizing it and generating some content. So if that sounds interesting at all, even if you're like, yeah, I wouldn't pay for that, but that still sounds interesting, go give me your thoughts. I'm interested to hear what people think about that. So there's a little landing page there. You can do the QR code or type in the landing page. And I'll send this out in the email with the video of this. So if you miss it, you can get a chance to do that. But I really value your feedback. I will email Hannah Lawrence. That's very good. H-A-N-A-H Lawrence, L-A-U-R-E-N-C-E. Great. I will do that, and I will make sure that I talk to them. Somebody had suggested that I email the alliance partner people, so I will probably talk to them as well. So yes, I think this could be a really great idea. I think it could go really well. I just need some more feedback as far as like how much people would be willing to pay for this and what they would expect for whatever they ended up paying and things like that. So I'm hoping to have it ready, like, do some surveys in the next week or two. And then after that, launch maybe like around January or something. And if you sign up for this and if you express interest early, I will give you guys some kind of a discount. Whatever I come up with, there will be a discount for the people who help me out by signing up early. So, and then another reminder, and this again got messed up. I don't know why. I swear, I just added these today, so I don't know why. But if you ever have a LabVIEW problem and you're not quite sure where to go, or you want some advice or whatever, you guys can always sign up for a free 60-minute phone call. It's an hour long. It's not really a sales pitch or anything. You just sit there, we talk. I ask you a bunch of questions about what you're working on and what kind of problems you're having. And I guarantee you at the end of 60 minutes, I can help you identify what your biggest problem is and point you in the right direction. That may involve me trying to offer you some services or not, but I mean, either way, I know a ton of people. I've got a ton of connections, and I've got a ton of content of my own. And I know I've been to a bunch of the CLA summits and stuff, so I know what's out there, so I can point you in the right direction. So if you ever have any problems and just want to talk, use that link and give me a call. So questions about anything that we've presented today, test-driven development, unit testing, continuous integration, anything else? If you have any questions, now is the time. Otherwise, either stick around to see about the question. Unit testing with hardware. Okay, Mark, you should look up, I did a presentation on mock objects at the CLA Summit. So you want to look up mock objects and test doubles. So basically, you create a hardware abstraction layer, and then you either insert some kind of simulated instrument, which would be your basic test double, or you insert a mock object that basically just records all the calls that come and go from the hardware. And then you can verify that it's making the correct calls on the hardware. And that's basically how you do it. There is a toolkit that I put together for the mock object stuff. It's available. Let me put up where to get that. Hold on. All right, why is the test thing not coming up? If you go to getlab.com, SAS_public, there's a bunch of stuff there. The thing you want to look up under there is like the class refactoring tools or something, and that will install the mock objects and everything else. Oh, interfaces are totally going to change things for unit testing. Yes. It will make it much easier. So Well, actually, it will only make it much easier if people actually adopt the idea of programming to an interface and not an implementation. So that will still be a problem. Yeah, I'm not entirely sure that that was 100% public knowledge. They mentioned it at the CLA, so there is actually no guarantee that it's coming out. Steven said that if everything goes well, it should be here by 2020, but definitely know that NI is working on it. So, yeah. So for those of you who don't know, an interface is basically a class that has no data, but just overridable methods. And they've made some changes, or are planning on making some changes to allow you to have your normal inheritance that inherits the data and all the methods, and then something called an interface that you just inherit some methods from. So it's kind of a form of like multiple inheritance type thing. So yes, if you know what those are from other languages, that will totally change a whole bunch of stuff. Really, really useful. I want to say, and don't quote me on this, but I do believe it's also coming to NXG. So at some point, the NXG support might be a ways down the road. But you know, somewhere on the roadmap. So, all right, other questions? Anyone else? I will make a recommendation. If you go to refactoringguru.com, Stefan put me onto that, and I'm not 100% sure I have that correct, but Google it. There's a guy called Refactoring Guru, and he has a book on design patterns that is quite good. It's similar to the Gang of Four book. It lists all the same design patterns, but it's a little bit easier and more approachable. I've just been reading that lately since Stefan recommended it, and it's quite good. And it also does some other stuff too. It talks about, there you go. The design patterns book also talks about solid. It gives probably the most concise description of solid that I've seen, and understandable description. And it talks about basic OOP principles as well. So it's really good. It's not even comparable. It's like comparing like seconds to like hours. They're not apples and oranges. So that's the best presentation I can do. So thank you, Luis. I'm glad that you found it useful. Yeah, if anybody has any recommendations for what they want to see next, let me know. I was thinking refactoring, because we talked a little bit about refactoring here, and once you get that whole mindset of writing unit tests, then I think refactoring is a natural thing that flows off of that. So if you want to see something else, let me know. Send me an email. I'm happy to think about that and see if I can come up with some content on other subjects as well. So, all right. Well, thank you all for taking your time. I appreciate it. I realize it's an hour of your day. Hopefully you found it useful. So thank you all. All right, I'm going to sign off now. So if you have another question, now is the time. You can always email me or sign up for a free phone call. So thank you.